covered a couple things that you heard about in some of the previous slides. The contention period, where basically a bunch of hosts, stations, computers, however the network's hooked up, they'll start fighting for the channel. Collisions still occur in the contention period, even with the protocols we talked about before. Main part about it and the main solution we want is to basically get rid of the downgraded performance. I'm just going to cover a couple topics. I'm going to not go super into detail with it, just give you the main example so you get the idea and you kind of understand what it is. For that, I was going to see if I could get 4 volunteers to help me demonstrate it. Right here. Appreciate it. 2 more. It's not very hard. Pretty easy stuff, guys. Shouldn't challenge you too bad. I will tell you, if you do it, you'll probably never forget this. And I'm going to do it, I know it in my mind left to right, so I'm going to have one computer, whoever wants to be the first computer there. Another, if you want to stand on the other side of the table so these guys can see you. Just, if you want to stand, I got some little prompts for you, and I'm going to kind of work you through it as we go along. The first solution is the bitmap protocol. So we're going to assume everyone's connected back to a network, okay? You got your prompts in front of you, okay? The way bitmap works, as you see, basically I've just compiled it to a waiting list, all right? So it's going to be a waiting list for this one. Contention period starts, if you just want to look up your bitmap prompt, guys. We're going to go in order, and we're going to start saying who's going to go first. We're going to start with computer 1. Who's computer 1?
I am computer 1.
What do you got for bitmap?
I have frames.
You have frames? So you want to send?
I send first.
And you're going to send first. So first up, we got somebody with frames, and he's going to send first. We're going to add it to a list, though. He's not going to send immediately. What you got?
No frames, skip me.
Skip you. You're done. We're not even going to add you to the list.
No frames, skip me.
Skipping that, man. We only got 1 person on the list. Nice and easy so far.
Right, I have frames. I send forth.
Send forth. So we have the list. He's right here. He's right here. Once we set up that list, then we all send. Who all have frames sent? So first, fourth, they sent. That's basically bitmap for you, okay? And I've kind of bolded out some of the main parts about it. Each station can say it has frames to send during its slot only. So we're going to set up, and it's going to be first through fourth every time it happens. It's a predefined, a pre-set up list of order computers. Whoever goes first, you have frames, yes. Set up the list, then send the frames. Once all slots are known, they transmit. I think you might have heard slots in one of the previous slides. They cut it up into slots and do that. And after all transmissions, another contention period occurs. This is a reservation protocol. Obviously, you're making a reservation on the list, and that's pretty much the gist of bitmap. Did anybody try? You bought candy, right? Does anybody see a problem with that protocol at all? Some of the math people? Not super calculus, just a very basic problem with that. Who do you think is actually going to benefit most in that?
The way the ones.
Anybody else got an opinion on it? Most people assume he's going to benefit, right?
Right.
You know.
It's actually biased. Yeah, 1 second. It's actually biased towards the later hosts, because if we're going through contention periods after contention periods, like let's say we start another contention period, scan through, and we get to here, he now has frames to send. We're going to get here, he says, I have frames. So he's going to be first up on the list. Then he's going to tell me I have frames. We've made the list. He's actually going to send before he gets to send. So it's biased towards the people, towards like the latter hosts. Just give that man some opinion. That's my go-to right there.
Oh, we got multiple candy.
All right. Pretty good idea about bitmap. Just 4 host computers want to send information. That's how it's done. Token ring. We might have said something about this in an earlier presentation. I think we did. Okay. A misconception about token ring is that it actually has to be in a ring. I've even got right there form circle. But the topology can be different within a network where you just basically span the hosts, but logically they're a ring. So I'm not going to have you guys form a circle, but if you will kind of read your prompts on the token ring, we're going to say this is a token. Okay, So they're going to pass a small message called a token from one station to the next in a predefined order. We're also going to start down here again. My first person.
All right. I have token.
There's your token.
Sending frames to C2. Passing token.
Passing the token. Okay, sending frames to C2. Everybody hear that part? So sending frames to computer 2. What do you got?
I received the frames, I received the token. No frames to send, passing the token.
So we got the frames from the first one. The tokens are going out as soon as basically the token goes out, okay?
I received the token, I have no frames, passing the token.
Alright, I received the token, I have frames to send to C1, and I'm passing the token.
Okay, and let me start right there. Hold up before you go. Oh, see, he's already figured it out. I was gonna ask, if we weren't in a circle, where was that token gonna go? It would go right back around to him, but it doesn't actually have to be in a physical circle. They'll show you, there's a picture I have later. You see an actual circle, it actually doesn't have to be that way. You can just have it logically. But I will say this, the difference between that, I did that so you can kind of understand it. As soon as that man has the token and he can send something, he goes ahead and sends it. It goes down the line or around the circle and the person grabs it off. It says, oh, that's for C2, that's mine, I'm pulling it off the wire, sends the token. So the token, the messages don't go right with the token, okay? That's the only difference I want to make sure you know. Some of the big advantages of this are the no bias thing that we talked about in the original. It's a circle, so everybody's kind of getting it at the same time as they do. As they send, they can receive, and then they get the token, so it's not biased. The token does not need to propagate before the protocol advances to the next step. Any questions on that one? Does everybody understand it doesn't have to be in a circle, it doesn't have to be a ring? Okay. It's just more or less, it's still going to be in a list. A circle can be a list, but it's just going to straighten that circle up. Binary countdown. I simplified this to top dog takes priority. You can look in your book and it's going to tell you how binary addresses are used to say, I'm higher than you are, I'm more important than you are. So a station wanted to transmit broadcasts its address as a binary string. Now this implicitly assumes that the transmission delays are negligible. This is why supposedly it's better than most. What do you have for this?
I want to send to address 110.
So that's your address, I'm sorry. You want to send, what's your address?
My address is 1100.
Hold right there for a second. Sure. You want to send, that's your address, right?
Yes.
Okay. Next person down the list, what's you?
I want to send to address.
You want to send and you have an address. Okay, that's your actual address, sorry. So this man wants to send, what's your address?
Binary 10 or 1010.
1010.
I don't want to send.
Don't want to send, we're skipping that man. What's your address though? Put this address on the side. Right beside that address. What's your address?
0011.
0011.
Alright, I want to send
What's your address?
0101.
All right, you look to the right of the binary countdown protocol. Who's the top dog?
I'm the top dog.
Yep. Does anybody know why he's the top dog?
To say different.
Why is he the top dog?
The ones.
What? It's ones?
Yeah, it's the ones I'm in the first place.
Okay, so basically the way the book has it set up for you, I'll show you. I don't know if everybody can see this, but let's just say that was this address. Let's say that address was first in the line we're going. As soon as it gets this address and sees 11, it's canceling that first one. It says top dog spoke now. Sorry, little peasant, you have to wait till next time. Okay, there you go. But top dog, you got your message across. Who else has packets to send? 1010? So he would actually go second, right? Because binary. I don't know if you guys are familiar with binary. Okay, but yeah, then this guy, he had packets to send. He'd go last. Okay. And that's basically how it's done. And that way, let's just break it down on a campus. Students and professors share the same line. Who do you think is going to get their traffic sent first?
The professors.
Well, I would like to think we're top dogs, but yes, they're going to get their package sent first. Hey guys, I really appreciate your help on that. Thank you so much, guys. And as you see here, they see bits instantaneously, okay? Higher address stations have priority, simple and very efficient. And this is what the book wanted to show you. So maybe you might understand these more than what we just did, but I did not. That's your slot contention. This is more like a technical breakdown. You see the slots of the stations. Those are the frames they want to send. They say they have them, so they put ones in the slots. That's basically like the list. Okay, we went over that. Here's the token ring that you'll always see in a ring formation. It can also be flat. You see them going in the same direction. They go to the right. I was thinking back to the left for some reason, but yeah, you can send it whatever direction you want. And there's your binary countdown. And it's basically, it sends a 0, quiet, 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 till it hears something higher, I'm assuming. And as soon as it hears that address right there, it's saying, I'm going to let that one happen. And that's how you do the binary with it.